Everyone, welcome back. In the last video, we discussed about the agents, the agent architecture, the various design patterns exist for the agents, and the different levels of systems, specifically multi-agent and self-evolving agent. So, what does the agent consist of? It consists of the LLM. Uh, it consists of the LLM. The hand represents the tools, and lastly, the orchestration layer, which actually controls the LLM and then the tool, and to give the desired output to the user. So basically, it plans, executes until the desired output, the goal is achieved. Today, we will be focusing on tools, specifically how LLM decides which tool to use and how the whole function calling process works. But we will also discuss on the model context protocol. It's called famously called MCP, and we will dive deep into how MCP fundamentally solve the tricky M by N problem. We will also cover why this protocol is uh, so important, and what the structure looks like, especially the roles of MCP server and the MCP client. We will also briefly touch upon the security aspects. MCP itself is a big topic, and we can't talk about everything in just one session, but by the end of today, you will clearly understand what MCP is and how it works and why it is so important that most companies are choosing to use it. Let's start by understanding how ChatGPT works. Imagine you ask what's the capital of France. ChatGPT takes your questions and sends it to the language model. For example, GPT 4.1 or GPT 5. The model then figures out the answer and replies. The capital of France is Paris. Let me show you in the actual ChatGPT. So the ChatGPT gives the answer as the capital of France is Paris. Sometimes it also gives some additional information about the city. But what if I ask what's the weather in the Paris right now? Let's check. I can type this. What's the weather in the Paris right? Yeah. So the ChatGPT responds back saying that it cannot provide the real-time data or the live data, and it also suggests us to use the Google Weather and the other weather apps to to get the real data. Why is it so? That's because the LLM is pre-trained on general topics and facts. So it can't provide the real-time data or a live updates from its memory. Since information like the weather changes constantly, the model needs to use an external tool to fetch the most current data online. So without access to such tool, it cannot accurately respond to the questions requiring an up-to-date information. Correct? And now if I log in to this tool, or sometimes when I enable the web search and try to answer and try to ask the same question and then explicitly say use a web search tool, use a web search tool. Let's see what ChatGPT response. Yeah, it still gives us the same response, but this time I will log in, then ask the same question. So now watch closely. The moment I click on the enter button, you for momentarily you see search on the web, and it shows the current weather, which is 6 degrees in Paris right now. And this also works specifically in all AI applications. So if you search for in Google AI Studio, also it's the same thing. See, whenever I asked what's the weather in Paris now, and it has given back the response that the 6 degrees The temperature is 6 degrees right now in Paris. So in short, for all the static questions, the the facts that don't change, the AI answers from the memory. But for dynamic questions, the AI uses a tool to get the latest info. So when the user sends what's the weather in Paris now to ChatGPT, ChatGPT sends it to LLM. LLM uh, process the questions and then finds out that it can't answer from its pre-trained information. So it selects one of the inbuilt tools it has already, like web search. There are uh, other inbuilt tools available, but in this case it will search. It will take the web search, calls the web search, and then gets the result, and then sends it to ChatGPT, and in turn ChatGPT sends it to the user. So in our case, it's a 6 degrees in Paris right now. On the next slide, we will be looking at few more built-in tools. But for now, you know that LLM uses external tools to answer the questions it doesn't know. So there are three types of tools. One is the built-in tools that come with the platform. As you just saw, the web search is one of the built-in tool where when the user asks a question, "What's the weather in Paris?" Uh, it uses its inbuilt web search tool and then gives us the answer back. And we have an agent as a tool. We can also make agent as a tool, and then we can build our own custom tools. Yeah, before I show you the various inbuilt tools we have in Google AI Studio, but I want you to understand how it works. So, as I said in the previous slide, when the user asks this question, "What is the weather in Paris?" to Google AI Studio, Google AI Studio sends this question to the LLM, and LLM figures out that it can't answer this question, so it searches for the tool. We call it as tool calling, and from that it selects the web search tool and then looks for the methods or the functions which have been defined in it. And it also is called function calling, where it says get weather is one of the function using which it tries to answer to the user question. So this whole tool calling and function calling, technically it's called as function calling because the tool calling happens, I mean, it happens very fast. So this 4 and 5 steps are combined called as function calling. And then the LLM formats the function call. So it does not execute the function because LLM is only has a memory or a pre-trained model with all the data in it, but it does not have the uh, ability to execute a function. So it only calls the function, understands its structure, then makes a structured a request. Okay, and then it sends it to the Vertex AI, because the whole thing is under the Vertex AI. The Google AI Studio, LLM, and these tools are all under the one platform. So the Vertex AI manages as an orchestrator. So this is sent to the Vertex AI. Vertex AI identifies, uses the inbuilt APIs it has, executes that function, and sends back the tool output to the LLM. And then the LLM summarize that output and then sends to the Google AI Studio. In turn, it sends the response to the user. So this is the inbuilt tool workflow. Now we will see an example how it works in the Google AI Studio. So as you see in the right side, there are tools where Google AI Studio provides us one, two, three, four, five, five kinds of tools. It provides inbuilt tools which is provided by the Google AI Studio. So the first one is the structure output. As the naming itself suggests, it's a feature that forces the AI model to respond in a specific format. So LLM is pre-trained in a way that it always outputs a text format, but we can also force it to provide in a specific format. For example, the most commonly used format is the JSON. So why do we need a JSON? So in a real scenario, you will be building an application based on the LLM as as a central component. You will be building the application. So if you are building an app, you can't easily use a paragraph of text in your code. So you need variables, numbers, and list. So the structured output bridges the gap between the human language and the computer data. Here the user can type anything and it will provide you the answer. But in real time, when the user accessing your app, then the app has to call multiple APIs. For it, it has to be in a structured format. So mostly it's a JSON format. So I will just now demonstrate with an example how this looks. Okay. As an example, see, I am now typing this as if the user has typed in your application and he's planning to buy a Nike shoe, preferably. But your app actually calls the Amazon website and then tries to see if the Nike shoe stock is available on Amazon. If it is available, then you will go ahead and buy in for the user. So now, if I click on run, okay, first I'll show you without using the structured output. I'll show you what it returns. It has written a full text. You see, this has written a text which the LLM by default does it. So it doesn't give you in a format which the API understands. That is in a JSON format. But if I now enable this and then type it again the same question, now since the structure output is enabled, it provides you in a structured format. Okay, so category, brand, model, color, model, size, sentiment. So this you can define it over here. So in the structured output, come to visual editor and then you can define all the information which you want to pull it from the text or which is required for your API to post it to Amazon or any other e-commerce website to get the information. So it's category, brand, model, color, size, sentiment. So it will try to analyze the user question and then understands each one of the variables and try to fill in the values. So so in this case it is category. So the running shoes, brand Nike, model Air Max, color, size. So you see whatever the user has put in in his request, it actually formats in the JSON format. Okay, and then maybe I can put another example where I say I'm not happy. So what is a sentiment analysis? Now it returns me in the JSON format only the sentiment analysis, that is which is negative, but it does not have other information because the user has not provided it. To showcase you again the structure output, maybe we'll define one more parameter. Maybe here I'll just change this question. Shoe probably Nike, especially Air Max. Uh, and my age is 30. Okay, now you also want to know what the age when you are trying to send when you're trying to format this in the API format and then sending it to the e-commerce website. So here you will come, so here you will find there is no age defined here, so you can add a property called age, and age would be in the format of string. Okay, now let's see if I run this user question again. Let us see if it is actually pulling that information. See, it is automatically has extracted the information and then it is mapped to the age because it understands that the variable, the age, then it goes into that user's query and checks whether what's the value of the age and tries to map it to the age variable and then returns back as a JSON format. Okay, next let's see the code execution tool. So here, whenever you ask a question, so instead of just predicting the text or guessing an answer, the AI acts like a programmer. It writes a script, executes it, and then returns the result to the user. So maybe I will show you with an example. So let's first not okay. First, let's not use the code execution and see what response we get from the LLM or the Google AI Studio. So my query is to create a chart showing the growth of $10,000 investment at 5% interest over 10 years. So without code execution tool enabled, the AI writes a text description of what the chart might look like or tries to estimate the numbers, possibly getting the component. The code execution enabled the same user query. This time the AI writes a Python code using the compound interest formula. It uses a plotting library, matplot, matplotlib. Then it runs the code to generate the actual image file of the chart. So this is the actual image of the chart, and then it displays the image to the user. So this is how the code execution tool works. So without code execution, the response of LLM would be in a textual format, but with the code execution tool, it writes a Python. It executes that Python in its isolated environment, and then it gives the results in a graphical way. That's the advantage of using the code execution tool. Next is the URL context tool. Maybe to show that with an example, you can see this URL where it's mostly about the food related recipes and inspirations, kitchen chefs, and shows. So let's go to this one, and then if I now copy and paste it in the as a user query, and then if I run it without URL context enabled, it says it does not have enough information to provide a specific recipe of this from the food network of UK website. So basically it doesn't provide you enough information, so it's not able to extract that information from the provided URL. But when I now enable the URL context, then type in the same URL here, you can now see the difference. See, this time it went into that URL, extracted all the relevant information, and then giving the user the response. So it responds in a very structured way. So in the without URL enabled, without the URL context enabled, it did not provide us the much information. But with URL context enabled, now it provides you much more information, where because it was able to extract that information and then provide you in a structured format. We have covered how tools like external APIs and code executions work. So these are part of inbuilt tools. The next kind of tool is making AI agent itself as a tool. So here, if you see when the user sends a query, there will be a primary agent which takes charge, and this agent consists of, as we all know, has three components: large language model, a tool, and orchestrator. The LLM processes the query, and the orchestrator manages the interaction with the tools that retrieve the necessary data. So if it needs to also talk to another agent, then so in this case, if the data needs to come from a structured sources like databases, the structured data retrieval module is triggered. Alternately, if the query requires information from external sources like Google connectors, the module can be used to pull in the real-time information from the web. So once all the pieces are in place, the system returns the exact response what user has asked for. Next is we can build our own custom tool. So how does this work? So previously, when you use when you saw the inbuilt tools where the Vertex AI acts as an orchestrator and then executes its inbuilt APIs, but with the same process for the custom tools, it actually works a little different. Where if you ask the same question, what is the weather in Paris? The Google Studio calls LLM, does the tools calling, and it makes a function calling. So here it formats the function call and then it sends to the AI studio. And the AI studio, I mean, it formats a function call means it has the JSON request. It makes the request. It doesn't execute the function, but it makes the request and then it sends it to our application or the user, and then the function defined in our application will get executed. So, yeah, we will see more in detail about how to make a custom tool in our program. But here, you only have to understand is the LLM will never execute a function, but it can only make a request in the format where what the function looks for. So in this case, the it makes a request in the JSON format. So we have a provision here in Google AI Studio to have a small custom function. So here I will enable the function calling, and then I'll come here, add get weather description, get the current parameters, add property. I'll say city. Now, if I ask the same question, what is the weather in Paris? So, if I now ask this question again, this time, see, this time it will actually gives it does not give us the result, but it makes a structured request to execute the get weather function. So we have defined a get weather function where it will the city as one of the parameters. So it already knows what request needs to be sent to be able to execute that function. Now it is waiting for the response. So in real time this will be sent to the application, but here also here in this Google AI Studio it is actually waiting for the uh, user. So it acts the user in himself will act as an application. So if I put say 34 degrees, okay, now this again will be sent to the uh, LLM, then LLM summarizes it and then it returns the value to the user. So if you understand, in the first time when we actually noticed the Paris, the temperature was 6 degrees, but now whatever the application or the user enters this value, it returns that value to the end user, the 34 degrees. That so this is happens because of the use of function calling, where you can define your own custom functions. So I have defined my own custom function here, and the parameter as city, and in real time you will have a Python function which actually uh, calls the actual external API like weather.com or some Google web search, and then tries to get you the real result.